plus X, which is all user, user group, and other at execute. So you don't really have to use the A ever. If you don't put anything before the arithmetic sign, it assumes A. So just be careful when you're doing that. If you just do CMOD plus X on a file, you just gave everyone on the whole system the ability to execute that file, which may not be what your intention was. And a lot of people use that as a shortcut sometimes. So this can be a little easier sometimes. What's useful about the octal method is that, say you wanted to set the user permissions to, read, write, execute, and the group permissions to, just read, execute, and other with no permissions. You would either have to write 3 different commands in order to do that with the symbolic method, like we did here. Let's say that, let's say we wanted to do U plus, read, write, execute, and then, or let's say we wanted to do it equal to. Group, we wanted to do equal to read and execute, and other, we wanted to do equal to nothing. So we would have to run this command either 3 times, like this, or I believe there's actually some options that you can use in order to do all 3 of these in one command. You'd have to look at the man page to kind of figure out exactly how to structure that, but I think it is possible. Regardless, whether you did 3 individual commands in order to set all these permissions on a file, or you use them all in one command, it's still a lot more cumbersome than just writing CMOD 750 on a file. So that is where sometimes the octal method can come in handy, is when you need to set all the permissions for user group and other to something very specific. The symbolic method is really useful when you're just needing to add like one individual permission for either user, group, or other, or you just want to remove a permission, just one permission or something like that from user, group, or other. It really just depends on exactly how you want to use it. But that is both the symbolic and the octal method of using CMOD. Now we're going to go in and look at actually using the command a little bit more on the system. So I'm now logged into the system as the user student. I'm going to cd to the directory we were using earlier and /temp/tester, print working directory just to show you where I'm at. Now throughout this course you may see me use this command called ll. It's not really a new command. It's essentially the same as ls-lh. You can see the output's the same, and it's really just an alias. So if you type which ll, this will show you exactly what the command is. It's just an alias that makes it run ls-lh whenever you run ll. And if we do a man on ls and look for tach, we can see that tach just gives you a human readable format of file sizes into megabytes, gigabytes instead of all bytes. So that's really the only difference there. So looking at the files and directories in here, we're going to start with changing the permissions of this uNotModify file at the very bottom. Currently it has the permissions of read on the user, read on the group, and read write on other. So I want to change these permissions to read write for user, read write for group, and just read for other. So the way we would do this, if we remember counting in octal, remember read is 4, write is 2, execute is 1, and we just add them up. So if we want read and write for the user, well, read is 4, write is 2. 4 plus 2 is 6. If we want read and write on group, read is 4, write is 2, 4 plus 2 is 6. And for other, we just want read. So that would just be 4. So 664 on the unotModify file. Now if we look at the permissions, we can see that we have read write for user and group, and just read for other. So that is how we would change it in octal method. So now let's do something in symbolic method. For the no one read directory, we see that the permissions are currently just all execute. Well, I want to change these permissions to read, write, execute for the user, read and execute for the group, and no permissions for other. Let's do this symbolically. So CMOD, we want read, write, execute. So U equals read, write, execute. We can see that that set the permissions for the user equal to read, write, and execute. Now we'll do the plus method next instead of the equal to method. So for group, we want read and execute. So I'm going to say CMOD G plus R. So for group, add read. If we look at the permissions again, we see that they are read and execute. That's exactly what we wanted. And for other, we want to get rid of the execute. We just want 0 permissions for other. So CMOD O minus X. And we can see that that subtracted or removed the execute permission from other. So that's pretty simple. That's how we would use the symbolic method to change permissions. Hopefully that kind of makes sense there, and you can see that learning and figuring out the octal method, while at first seems a little confusing when it comes to setting permissions, if you get to the point where you can just realize that R for read is 4, write is 2, and execute is 1, and you just add them up, it gets a little bit simpler. You'll be able to quickly just say, okay, I want to give permissions of 6, or 7, or 5, or 4, or 3, or 1, and you'll know that one of all those numbers basically are equivalent to a permission set of read, write, or execute, and you have to have 3 of them for user, group, and other at a minimum. There are some more advanced permissions that we will talk about a little bit later in the course. There are additional permissions that are set UID, set GID, and something called the sticky bit that will give you a 4th number to the CMOD command. But don't worry about those right now. We'll get into those a little later and what their purposes are and how you can leverage them when setting permissions on a file or directory.